Mathematics translates words to diagrams and symbols. So for example, here you have a paragraph with some English words. There are 3 children in a party. A set of 14 whole cakes are to be divided equally amongst them. How much cake does each child receive? So therefore, the task at hand is to equally divide one set of 14 cakes between a group of 3 children. As you can see, important words such as equal has its symbol heritage. The word such as divide has its symbol heritage. The word 1 has its mathematical symbol heritage. The word 14 has its mathematical symbol heritage. And just to confirm the translation of words to symbol, the word 3 has its symbol. So mathematics convert words to symbol. And here is a specific case. We want to equally divide a set of 14 cakes amongst 3 children. Mathematics also use diagrams to translate words. So the word C-A-K-E, cake, here's a diagram for it. And the word children, C-H-I-L-D-R-E-N, you can use a rectangle. So here you have 14 cakes and 3 children. Okay. So you want to equally divide the 14 cakes. So what we can do, we can give a first child a cake. Okay. We move on to the second child, take a cake and give that child a cake. And take another cake and give it to the third child. So now each child has a cake. Now there are plenty more cakes left. So let's repeat the process. Give a first child another cake. The second child, give that second child another cake. And give that third child another cake. Okay. We still have more cakes left. So we can continue doing this. A third cake to that first child. Second child also gets a third cake, and the third child also gets a third cake. So all 3 children have 3 cakes each, but there are still more cakes. Actually, there are 5 cakes left, so we can give each of the 3 children another cake. Agreed? So here it is. Good. Now each child has 4 cakes. Now there are 2 cakes left, so we cannot repeat that same process, because if we have to do it that way, one child will be left without a cake. So what we can do, we can take 1 cake and slice it into 3 equal pieces. So that's 1 out of 3 equal pieces. So that's not a whole cake right here. That cake is 1 out of 3, because we are slicing this cake into 3 equal pieces. So that's another 1 out of 3. And another 1 out of 3. So this cake here has been sliced into 3 equal pieces. Each child gets 1 out of 3. So 1 more cake is left, and this is going to be repeated. So what we can say in words, each child gets 1/3. So this cake, the value of that cake, piece of cake here, we can call it 1/3. Okay, bear that in mind. 1/3 is just like saying 1 orange or 1 mango. 1/3. Okay, bear that in mind. Now we can repeat that same process with this other cake. That's the last cake that is left. So this first child gets another 1/3. So that is 2 thirds is just like saying 2 mangoes or 2 oranges. Here we have 2 thirds. Okay, so this child now has 4 cakes and 2 thirds of a cake. Remember, we are splitting this one into 3. So this child gets 1/3 already, another 1/3. This child can get another 1/3, and there is another third that is left for the third child. So this cake here has been equally divided into 3 slices. Each child gets 1/3 of that last cake. So as you can see, each child has 4 whole cakes and 2 thirds. Okay, third is like a noun. It's just like saying 2 pencils or 2 books, 2 thirds. That's 1/3 and 1/3 will give us 2 thirds. Okay, so we can conclude, therefore, each child received 4 whole cakes, and here's the symbol for 4, the translation, mathematical translation for the word 4. Each child received 4 whole cakes and 2 thirds. Okay, and the symbol for 2 thirds is 2/3. Okay, so consequently, 1/3 of 14, that's 1/3 times 14, because the word of in fractions has its symbolic translation, which is the multiplication sign. So that's 1/3 times 14 is equal to 1, 2, 3, 4, and 2 thirds. Okay, a third times 14 is 4 and 2 thirds. 1, 2, 3, 4, and 1/3, 2 thirds.